Problem number 4. How many three-digit numbers satisfy the property that the middle digit is the average of the first and last digits? Alright, well, I'm just going to call this number, it's a three-digit number, and I'm going to call the digits A, B, and C. Okay? And so what this is saying is if we take A plus C and average them, then we're going to get the middle digit B. Okay? So what that tells me, first of all, is that A plus C must be even, right? So A plus C is even. So then either A and C are both even, or they're both odd. Okay? Makes sense because an odd plus an odd is an even, and an even plus an even is an even. If they're even and odd, you get an odd on the top, and when you divide it by 2, you wouldn't get an integer, and you know, B, the middle digit, has to be a digit. You know, we can't have 905 and a half, you know, the middle digit has to be an integer. So let's look at those cases, okay? So again, I'm going to do casework in this as well. So case 1, let's consider A and C are both are both even. Okay, so that means they'd have to be 2 or 4 or 6 or 8, right? Those are the even digits that we can use. And so we have a three-digit number, right? So if we choose the first digit, we'd have 4 choices for the first digit, and we'd have 4 choices for the last digit, and then the middle digit is just going to be determined by the average of the two of them. Okay, so there's only one choice for the middle digit. So essentially we have 16 possible numbers where the first and last digit are both even. So now let's look at case 2. Let's say A and C are both odd. Okay, so what are we dealing with there? 1, 3, 5, 7, and 9. Okay, so we have 5 odd digits. And so again, we can just look at, we have 3 digits, so we'd have 5 choices for the first, 5 choices for the last, and the middle one is just going to be determined by the average. Okay, so there's no choice there. So we'd have 25 possibilities where A and C are both odd. Now we can't forget about 0. We could have dealt with 0 up here in this case, but 0 is not technically even, so I'm going to deal with that case separately. Also because if this is a 3-digit number, it says it has to be a 3-digit number, so a 3-digit number isn't going to start with 0. Okay, so if we have so this is the case where C is 0. Okay, and if C is 0, then A is even, right? Because if we add A plus 0, we have to be able to divide it by 2. Alright, so let's take a look at those same 3 digits. And so for the first number, that can't be 0, otherwise it won't be a 3-digit number. So we have 4 choices for the first digit. You know, it has to be even, so it's 2, 4, 6, or 8. The last digit, we're just saying that it's 0, so there's 1 choice for that. And then there's 1 choice for the middle digit because it's going to be determined by the average. So there are going to be 4 cases where C is 0 and A is even. Alright, so we have 16, 25, and 4. 16 and 4 is 20, plus 25, so that totals 45 possible numbers where the middle digit is the average of the first and last digit. So there you go. Now we could have done this another way. You know, we could have just said, okay, in this case, that we have 4 choices for the first number, and then we would have 5 choices for the third number if we allowed the last digit to be 0. So we could have kind of combined case 1 and case 3, and then this would have been 20 and 25, and then, but it still gives you the same thing, 45. So the key is to break it down into the cases, you know, where A and C are both even, A and C are both odd, and then deal with the 0. So there you go, the answer is 45.